Hey guys, welcome to the last Kivy game tutorial. So in the previous tutorials, we learned a bunch of concepts that are fundamental to developing games. And in this tutorial, we're gonna wrap everything up by using everything that we've learned to create a somewhat decent game. The game that we're gonna be creating is an Alien Invaders type of game. So for those of you who are not familiar with it, it's basically like where you have a little cannon at the bottom of the screen and there's alien ships coming down from the top of the screen. You can only move left or right, so in other words, you can only stay on the ground, and you need to shoot the alien ships before they get to the ground. Every time an alien ship makes it to the ground successfully, you lose a life. After a certain number of lives, the game is over. Every time you kill one of these ships, your score increases. So that's basically what we're going to be trying to create. Now, quick recap. We've learned the essential concepts of developing a game with respect to Kivy. So how to do these essential concepts in Kivy. We learned about timing. So we learned how to schedule a function to be executed every so often. In particular, we learned how to execute a function every frame. And if you recall, we just used the clock.schedule interval function and we passed 0 for the number of seconds. That means call this function every frame. We also learned about rendering, which is another core concept in developing games. So the way that we render or we draw in Kivy is that every widget has a canvas attribute, and you basically add instructions to that canvas. And there's instructions such as rectangle, line, etc. We in particular use the rectangle instruction because that has you can also link it to an image, so that instead of a plain rectangle, it's basically an image that's being drawn in there. We also covered collision. In particular, we did a very basic form of collision, axis aligned bounding box collision, where basically the rectangles cannot be rotated. We also did some sound, so you learned how to play sound. Those are the basics of creating a game. Now, as I mentioned earlier, since we've learned those basics, we can use it to make our Alien Invaders game. So let's have a little plan here. You should always create a plan if you're going to create a project that isn't super trivial. So far, what we've been doing is very, very trivial, but right now we're kind of creating a complete product in a sense. It's going to be pretty shitty, but nonetheless, it's complete. So it is worth some time to sit down, think, and plan. I've already done a little bit of planning before I started recording this video, so let me share that with you. Okay, so here's a little, we'll start here. Here's a little diagram. This basically shows you how, like the structure, how my classes and attributes will be composed. So I'm going to have a game widget, and we know that the game widget has a canvas, and we have a bunch of drawing instructions inside the canvas. Now, these drawing instructions, we're going to be using in particular the rectangle drawing instruction, and it has some attributes, such as position, size, and source. Remember, the source is basically a string that says which file should be drawn inside the rectangle. And then we're going to give the game widget an entities attribute. This will be a set, basically a collection. And we're going to put these things called entities inside there. That's another class that we will define ourselves. Now, an entity is basically a position, a size, and a source, sort of like a drawing instruction. But it also has another attribute that points to the drawing instruction. So the entity knows the drawing instruction that is representing it. The reason for that is because when the entity's position, size, or source changes, we also want to update its associated drawing instructions, position, size, and source. So these two are always synced. In other words, the actual data value of the entity and the drawn or the visual representation stay in sync. So we have a bunch of entities inside the entities attribute of the game widget. That's the high-level architecture. I've also drawn this diagram, which is a class diagram, showing what we're going to implement. So we have this game widget class, which inherits from widget. You already know about this. This has an entities, which is a set of all the entities that are in the game. We have a score, And we have a score property, which is basically a getter and setter for the score. So that keeps track of how many points we have. We have a couple of methods. The add entity method basically lets you add an entity to the game. This will, when you add an entity to the game, so you're obviously adding it to this entity's attribute, but we're also going to take the instruction, the rectangle drawing instruction of the entity, and add it to the canvas of the game widget. And same, when you remove an entity from the game widget, we're going to remove its instruction from the canvas. And then we have two functions for checking collision. The first one, you pass it two entities, and it tells you whether they collide. The second one, you pass it one entity, and it returns all the entities that are colliding with that entity. I see those being helpful, so that's why I'm going to define this. Now, we're going to create an entity class, and this is basically what I went over here, but in code format. It has the position, size, source, and instruction attributes, and then it has some properties for them. So remember the properties are just getters and setters, and whenever the position, size, or source property is set, we want to update the respective property in the instruction as well. We also have this little function called stop callbacks, and all entities have to define this so that when it's called, anything that the entity has scheduled, it must be stopped in this function. And you'll see a use for that later. The next class we're going to define is a bullet class, and that is going to be an entity, and it's going to have a speed attribute and a property for it. And when you construct it, you have to tell it the position, but you get a default speed. So upon construction, the bullet will start moving up. I should note that there is a global game variable that refers to the game widget. So that's how everything will know that where they should be drawn and stuff like that. So upon construction, we will start moving up for the bullet. When the bullet is out of the window, we will cancel all the scheduled interval functions. So the bullet is moving up by using a scheduled interval event. And we will cancel that by calling the bullet's stop callback function. After we do that, we remove the bullet from the canvas. So now, when the bullet collides with an enemy, what we want to do is stop its callbacks just like before by calling that, and then we want to remove it from the canvas. Okay, so we got our plan here. Pretty simple, and let's go ahead and start implementing it. Okay, so let's clean this up a little bit. We have this test over here that just prints whether we're colliding or not. We no longer need that. And what else? I also should mention that this player.png and enemy.png that we had previously were those ugly smiley faces that I drew. I got rid of those, and I basically have some art that I drew inside this assets folder. So I drew a nice background, I drew a bullet, an enemy, an explosion. I drew all of these in Adobe Illustrator, and I drew a player. They're still not great, but better than the smileys that I had previously. And I also downloaded some sounds, one for the explosion, one for the bullet, and the music for the background music. They're all waves because for some reason on my computer, the sound API of Kivy can only play waves. And I'm not trying to spend time trying to figure that out right now, so I'm just using waves. Alrighty, so first of all, let's go ahead and start defining these classes. I'm gonna put my diagram here on the side. Well, I'm gonna put my class diagram, this one, on the side over here, so then I can look at it while I'm defining stuff. Okay, so the game widget we already have here. Let's give it a score property and all of that good stuff. So let's run. I like to run just to see where we're at right now. So it's just like before, where we have the player and the enemy, except this guy, let's remove him. We no longer need him. So with self.canvas, self.enemy, let's see where else the enemy is referenced. It's referenced nowhere else. Okay, we're just gonna remove it and run it, make sure he's gone. Okay, so we just have the player, but that ugly smiley no longer exists. Let's update the link for that player. I guess it's gonna be an assets/player.png. And there's the player. It looks pretty fancy. Okay. Nice. All right. Let's, I guess next, let's go ahead and take care of the score. Sure, why not? We'll create a score thing. So in order to do that, I need to go to from kivy.core, I believe, label, no, kivy.uix.label, import core label. Okay, this is how you draw text on the canvas. So we need that. Now we need to create, let's see. All right, I'm going to test it out really quick here. So I'm going to create a core label with test core label. Okay, then you have to call refresh on it. And then you have to, I'm going to move these up here. And then let's just create, I don't need this variable right now. Rectangle, I'll copy my code up here. So for the source node, we don't want the source, we want texture. For the texture, we're going to use the texture of the core label. For the position, we'll put it at, I guess, 300, so I can see it. For the size, you want to make it the same size as the labels, the core label's texture size. And let's make sure that that runs. There is a test core label, so we have we now have the ability to draw some text on the widget that we have over here on the canvas. Alrighty. Now we know how to do that, so we will get rid of it. We don't need it. Actually, let's keep it there, but move it into a function called set score or something like that. Let's see. So initially, I guess, where should we, I'm trying to think, when should we create the score label? It makes sense to create it when the game widget is first constructed. So over here. So after we listen to all the key, we initialize the root, we initialize the superclass, we listen to some keyboard events, and then we have this move step, all of this. I don't think we'll need that, but okay. Let's go ahead and do it right over here. So yeah, we'll just do it over here. Self.score, we'll call it score. And that's gonna be, we'll call it score label, actually. Oh my gosh. Okay, a core label, we will go ahead and do score and then 0 for now, like that. And then self.score label, refresh, and self, we will save the instruction as well. So score instruction, okay, is going to be a rectangle, and the texture is going to be the label's texture, and the size is going to be the label's texture size. Everything should be the same. Yes, there we go. Now let's position it in the top left corner. Alrighty, so we will position it in the top left corner. So instead of 300, 300, let's put it, for the X, we'll put 0. And for the Y, we will do window dot, did I import the window? Let me just make sure. Yep. So we will get the height of the window and move it 50 pixels down. Okay. So there we got a score and we got a player. Okay, good. All right, now let's finish the rest of the score code. So what we're gonna do is, let's see, should we create a, yeah, we'll create a property for the score. So we're just gonna create a Python property. Well, let's create a private like text for it. So we'll do self.score is equal to 0 initially, and then we will define a score property, and this is how you do it. This is a property. That's the getter. It will just return the score, and then we will also we will define another one. And let me make sure I do this. Yeah, so score self value, and this is going to be score.setter. So that's going to be the setter for the score. And in the setter, first we're going to set the private attribute, and then we also need to update the instruction, right? So first of all, we're going to go to our score label. We're going to update its text to whatever the new text is. And that is going to be an integer, so we will update it to string. Okay, and we will prepend score to it like that. So we're going to update the text of the core label, and then we're going to go to the score instruction. We're going to go to its texture. Well, yeah, score instructions texture, and we're going to set it to the score label texture. Okay, just like before. And then we're going to go to the score instruction, and we're going to update its size to be the same size as the size of the texture. So let's see, this setter will update the private score integer, then it will update the label's text, then it will update the texture and the size of the instruction. That should take care of it. Now let's go ahead and test this out. So we will, I guess, test it out right over here. Well, we don't need this print. I don't know why I have that there. So we will do set, well, we'll just do score equals, let's say 10, and let's see if this works. And there we go, score 10. So we have done that successfully. That works. So score getter, score setter, and all the score related stuff. All the keyboard listening. These we initialize the root, and here we draw the player initially and all of that stuff. Eventually we are going to get rid of the player because we're going to create an entity class for it. But okay, so looking back in our diagram, seems like I handled the score setting. So that works nicely. And now let's go ahead and define these add entity and remove entity functions as if we already have the entity. Why not? Okay, so we will now put it right over here. Okay. It takes an entity and it will add it. So it will go to self.entities and it will add the entity to its list. Let's go ahead and define that somewhere up here. This keys pressed thing, I don't like how I have that as a public I don't have it prepended with an underscore. By convention, it is a private thing. It really should be prepended with an underscore. So I am thinking about modifying that a little bit. But maybe later. We'll think about that later. So for now, we have the entities. It's going to be a set. Okay. Okay, so add entity. We add the entity to that set. Let's see if autocomplete helps us out. Self dot entities add. Oh, okay, forget about this autocomplete stuff. Okay, so our add entity function adds the entity to our set. What is it complaining about? The lint. Undefined variable self. What is this? Method should have self. Oh yeah, of course. Yeah. Okay. So that was a little silly mistake. So we add the entity to our list, and then we also have to add the instruction of the entity to the canvas basically. So we're gonna get the canvas, and then we're gonna add. Entities instruction. There we go. And we're going to do remove entity. What that's going to do is self. All right. So we're going to see if it is in first of all, and then we're going to remove it. So if entity in self dot entities, then we will go inside that and remove it. We will also remove its instruction. Okay, so we did the add entity, remove entity. Let's do the collides and the colliding entities. I guess we will do that. Okay, so let's entity 1, entity 2. All right. So we have this collision function up here. This takes a tuple of two tuples. The first tuple being a position, the second being a size. So we'll just use this function basically. So we will return, and what is that called? It's just called collides. We're basically just moving that definition over here, essentially. Okay. Maybe it's easier if I just move it. Why do we need this collides up here anyways? I may as well just take it and get rid of the global one here and just redefine it over here. Okay, so we have rect1x, rect1y, rect2x, rect2y. So we have two rectangles. X, Y is their top left for the first one, second one, and then width, height. That's what our algorithm depends on. The entities, how do we get that information from them? Well, for example, the x of the first rect will be the first entity. We will get its position. Let's see, and we will get the first element of that position. How do we want to keep the position as just a tuple, or yeah, why not? We'll just keep it as a tuple. So we'll just do it like that. We'll get the first element of the position, and that's rect1. And then rect1y will be, again, the first entity, the position, the second element. Rect2x will be, okay, so rect2x will be entity 2, position the first element, rect2y will be, oh, I forgot 2 here, position the second element, rect1 width, the width will be size the first element, rect1 height will be the second element of the size, rect2 width will be the first element of the size, and the second element for the height. Let's see if this works. I think that should do it. Okay, so this function returns true if these two things are colliding. And then let me think, do we need the other function over here? The one that basically gives you all the entities that are colliding with a particular entity. So let's think. When we have the bullet traveling, every time it moves, we want to know what it's colliding with. And we want to know if that thing, if any of them is an enemy. So yeah, we definitely want to know that. Let's go ahead and define that function. So, all right. Okay, so it will take an entity and will return all the entities that are colliding for it. So we will initially make our result an empty set, and we will add to that set as we find out. So we're gonna, for each entity in our set of entities, we're gonna see if that entity collides with the passed in entity. So if this entity collides with the one that was passed in, then we're going to add him to our results. At the end, we're going to return our result. So if you get no entities that are colliding with this entity, then you're going to get an empty set, which makes sense. All right, let me double check this because I often make little mistakes. So this function takes an entity, and its purpose is supposed to return all the entities that are colliding with this one. So I initially make my results empty, and then I traverse through all the entities that we have. If that entity collides with this entity, we add it. Oh, good thing I checked this. This shows you the importance of double checking sometimes. I would have figured this out through debugging, but it might have taken a bit longer. But I'm not checking for self-collision because this entity will be inside the entities list as well. So if it collides and they're not the same, so it does not equal entity. Yeah. I want to make sure this equality, I think this equality operator is identity. Okay, yeah. So they cannot be the same, then we return it. Excellent. Okay, so it seems like, let me double check, but it seems like we have defined the game widget class. We have a set of entities, we have a score property that sets all of our text correctly and all of that. We have an add entity that adds the entity to our list, as well as adding its instruction to the canvas. The remove entity does the opposite. We have collides, which tells you if two entities are colliding or not, and colliding entities, which returns you all the entities that are colliding with a particular passed in entity. Okay, now let's move on to defining our entity class. And let me refresh my memory here. So it just has position size source instruction, has some position size source property, and these properties basically just make sure to update the respective property in the canvas's instruction. And okay, so let's define our entity class here really quick. All right, I'm thinking about putting these in different files now, just because it's getting a little bit big. Maybe we'll move it later, but for now, all right, why not? We will define our entity class right over here. Let's use a little bit of the autocomplete here. Okay. Our entity does not inherit from anything. Okay. And let's see, do we want to initialize it? Probably. I'm thinking if we want to initialize it to anything, do I even need an init method for it? You know what? If I need it later, I'll make it later. Not a problem. Actually, yes, I do need an init. What am I thinking? But it doesn't have to pass anything in. The position, we will make it default. The size, I guess we will make default. And the source, we will make default. Sure, we'll do that. All right, whatever. That sounds good. So self dot the position will be 0, 0 by default. And the size will be, let's see, I guess 50-50, doesn't matter. The source, so I guess the source will be some bullshit. When the source isn't found, you just get a white rectangle. So the source will be some bullshit.png that won't be found. And then the instruction will be a rectangle instruction with the position same as this position and the size the same as our size. Okay. We got those, and let's create some properties for it. So we will define the position first. Oh, I don't need a semicolon. This is not C++. And what does the setter do? Well, first of all, it will update this private variable. And then it will call, it will update the instruction. Why not like that? Okay, just to make it a little more explicit what's going on. I will now go ahead and define the remaining properties. So the size will be similar. And the source will be similar as well. Alrighty, and the instruction, we don't need to do anything with it. So when the position, size, or source change, we changed the instruction as well, so that we're keeping the entity in sync with the visual representation in the canvas, the instruction. Now the stop callbacks needs to cancel anything that the entity has scheduled. well, this entity has not scheduled anything, so we don't have to define it in the base class. That's more of a requirement for the subclasses. Okay, so we did the entity. Excellent. Now let's go ahead and define the bullet. So to refresh our memory of the bullet, it just has a speed property, which determines how fast it moves, and then the constructor basically gets a position where it's created initially, and a speed, which by default will make 300. So upon construction, it will start moving up. When it's out of the window, it has to cancel whatever it has scheduled and remove from game when it collides. Okay, I think I got this. So we will go ahead and start implementing the bullet. All right. Oh no, not defined. Class. Bullet is an entity. Okay. Now it does have a init method though. And that will take I'm looking at my diagram here. It will take a position and a speed, which is initially 300. Okay. It will, let's see, it will, yes, self.position, it will save that. Speed, we'll save that speed. Position will, I think it just inherits that position from the parent. It will, there we go. Alrighty, excellent. Now let's create should we create a property for the speed, just in case they want to change it? Well, no, let's not create extra things that we don't need. If you want to, the bullet just gets an initial speed and it will just keep that speed. So we're going to just save it and then that's it and forget it. Okay. Now let's give the bullet a behavior such that when it's created, it will basically move up. So let me think about how we can do that. So when it is constructed, we're going to assume that we have a global game variable, right? So as soon as it's constructed, it's going to go to the game variable and bind to the game variables. Let's see. Yeah, for the game variable, we should give our widget an event that fires every frame, basically. That's what we should do. And then this thing will bind to it. So we're going to assume that that event exists. So we're going to go to our global game variable. We're going to bind to its on frame event. And what are we going to bind is our own callback. We're going to call it move step, I guess. Okay. Okay, that sounds good. Let's define that move step. Let's not forget to actually give that widget this on frame. Let's do that real quick. So we'll go back inside our widget, and over here where we schedule an interval, instead of calling move step every frame, we're going to call our let's see, our own function, which will emit an event. We will create a custom function here called onFrame. Okay. Alrighty, and what that will do is that will dispatch an event. So I don't know if I talked about event dispatching, but in Kivy, as long as your class inherits from an event dispatcher, our class inherits from widget, and widget inherits from event dispatcher. So said in another way, we are inheriting from event dispatcher, the game widget classes. So when you are inheriting from event dispatcher, it's very easy for you to define your own events. And then when you want to dispatch them, you just call your dispatch method. So I'll show you. So I'll show you really quick. I'm going to assume that I have the event. So all you do is self dot dispatch, and then you dispatch, basically you pass in the name of the event. So we want to dispatch our on-frame event. Okay. I don't really need this thing over here, but yeah, I don't really need schedule interval. I can just make a lambda here. Lambda takes ij, I believe, and actually, why not? We'll keep it. Okay, so we are going to dispatch our on frame, and we're going to pass in our delta time. Excellent. Now you have to also define a function by the name of your event. So on frame, and our function has a delta time. Doesn't have to do anything, and it probably shouldn't. And then in your init, we will have a section where we define our events. So we will do, let's see, got how to do this. All right. So we're going to do register event type. This method, along with the dispatch method, is provided to us by the event dispatcher superclass, which we're inheriting from again. So we are going to register an on frame. So once you register your event, you just have to dispatch it basically, and then you just have to create the method, and it doesn't have to do anything. Okay, so we register our on frame, and then we have it, and we dispatch it, and good. What do we dispatch it in response to? Well, we have every frame we're going to do that. Alrighty, so now we will go back to the bullet. So let's create a global game variable as well. So over here, where our build, so we will create a game variable here that's initially none, I guess, and then the apps build method will, okay, maybe we'll get widget, and we'll just return that. Well, I guess we don't even just do it there and just, yeah, there we go. So we create our game widget, it is global, and then our app instances build will just return that. And I don't think I need that because I'm not modifying it, so I don't need to declare it as global. Okay, there we go. So bullet, game.bind. So game.bind on frame. Whoa, I have it already up there. On frame, we're gonna bind it to our move step. So let's define our callback here. Just call it move step. Take a delta time, and what are we gonna do is the amount that we're gonna move will depend on the delta time, so we will do self speed times delta time. We covered this in a previous tutorial why we're doing this, so that it can move at a consistent rate irregardless of what system it's on. So there we go. We have that little delta time. Okay, so that's the step size, and the bullet we just wanted to move a little bit forward. It is an entity, so all what we're going to do is position Y. We're going to take the current position, self.position, the second component, and we're going to take that, we're going to add step size to it. That's going to be our new y. And now we're going to set that. So we're going to do new x self.position, and that won't change. So now we will do self.position. We're going to set it to that new x and new y. Only the y changes. Let me check this and make sure it's nice and clean. So we're going to move it up only. The step size is determined by delta time and speed. So if the speed is 300 and the second is 1, then we will move 300. That's good. And then new x, new y. The new x is just going to be the old x, and we have a property for that. Good. The new y is just going to be the old y plus step size. So moving up. And that position will be updated. Okay, and now we want to check. So we want to move it, and then we want to check it for collision. So, or do we even want to check it for collision before moving? Yeah, so let's say move. And here we want to do check for collision, basically, or out of bounds. So first we'll check for collision / out of bounds. So first we want to see if the bullet is out of the screen. So if the y position of the bullet is greater than the window's height, then we know that we're off the top of the screen. If that's the case, we want to basically unbind from the frame event that we're listening for the game widget. So we unbind our callback from that event, and then we remove ourselves from the game. And we get out of this. We are done. The other thing is we're going to check if we're colliding with anything. So let's get all the colliding entities. So for each entity in game.colliding, get everything that is colliding with us. And if the type, I guess if, let's see, how do I check the type? Is instance. Returns whether an object is an instance of a class. Yeah, okay, so if that thing that we're colliding with is an enemy, did I even define an enemy class? No, I did not even define an enemy class. But I guess we will have to define an enemy class. Anyways, so that's one more thing I'll have to add to my little diagram, or maybe we won't add it to my diagram and I'll just make it up. Okay, so if what we're colliding with is of type enemy, and then we will basically do some stuff. All right. Enemy. So if it's of type enemy, if what we're colliding with is an enemy, then similarly we will do these two things. So we stop listening to the on-frame event from the game, and we remove ourselves from the canvas. But we also want to basically ask the enemy to unbind. So we will tell it to stop its callbacks. And I guess we should move these calls into a stop callbacks too. So we will tell the enemy to stop its callbacks, and we will remove it. So we will do game.remove that. Okay. Yeah, let's go ahead and do that. We're going to define stop callbacks for this thing, and it will basically unbind from the game's frame event. And let's, instead of this line, in this line, we call our stop callbacks. There we go. Alrighty. So this looks good. Let me double check it. So whenever the bullet is moving, we check for two things, whether it's out of bounds or if it's colliding. So if it's out of bounds, first of all, how do we detect when it's out of bounds? We take its position attribute and we look at the Y. And if that's greater than window height, we know it's out of bounds. So then we stop all of our callbacks. The only thing we are listening to is the frame. We stop our callbacks and remove ourselves from the canvas so we can get cleaned up. And then we check for collision. The way that we check for collision is we ask the game, give me all the entities that are colliding with me. We're going to see if one of them is of type enemy. If so, we know we collided. In that case, we stop our own callbacks and remove ourselves from the game. And we also stop the enemy's callbacks and remove it from the game. So enemy, there we go. Okay, that looks good. And then if we also should return, and if none of that happens, then we will move. Okay, so that looks good to me. The bullet class seems to handle everything properly. Oh, I got a message. Let me just check it. I'm getting tired anyways. What is this bullshit? Okay. All right. Back to this. Oh man, this has been almost a freaking hour. I gotta hurry up. Okay, so we defined that. Let's go ahead and define an enemy class as well. So the enemy will actually be really, really similar to the bullet. It's just a different speed and a different graphics. It just moves down instead of up. I can probably consolidate that. It just moves down. I guess it has pretty different logic, so maybe I'll just create a different class for it. Why not? Okay, so we're gonna, that's also an entity, and I guess when we create them, do they require anything? No, not at all. Okay. Alrighty, let me think. So we want to move them down constantly, basically. Yeah, it really is going to be very similar to this thing. I guess we will hard code the speed. And for these bullets, yeah, the speed is 300, I guess. For the enemies, we will also have it take a position, maybe. Yeah, okay. We'll have it take a position, and we will have it take a speed. And we'll make the speed, I guess, 100 by default. And yeah, it's definitely going to be very similar to the bullet. And I should consolidate them, but I'm running out of time, so no time to think, just time to type. So we will save that speed, and we will set that position. Okay, and we will also bind to the games on frame. Sorry, I'm thinking. For me, thinking and talking at the same time is is it's pretty hard, as you've probably noticed. So I'll try to talk before I think. So what I'm doing here is I'm defining an enemy class, and the reason why I said that the enemy class is similar to the bullet class is because the bullet moves up and the enemy moves down. And basically everything else is the same, and I should really try to consolidate them into the same class, but that takes a little bit of time to think about that, and I just want to get this up and running, and then we'll clean up at the end. I want to see something. It's been too long since I've seen something. Okay, so now I'm going to basically finish defining this class. Define the move step. Another time. It's going to be similar, so forgive me, but I will copy and paste and change what you're not supposed to ever do. Okay, so it's going to be a little different because we're gonna check if it goes below. If the enemy goes below 0, so if it goes past the bottom of the screen, we want to stop the callbacks, remove it, and also, let's see, what should we do? Maybe decrease the score by a lot, I guess. Since we don't have any concept of life, the only thing I'm going to do is when the enemies move below the screen, you lose score. And when the enemies go above the screen, you gain score. I guess that's what I'm going to do. All right. This will be an endless game of maximizing your score. So we will game set score. Or game.score. We will increment, or we will decrement the score by, I guess, 10. We'll just say 10. Because you're going to lose a lot of score. All right. Well, what's this self? Instance of enemy has no stop callbacks. Yes. Stop callbacks. And it will be similar as the bullet. So it will just unbind its move step. Okay. And collision. So we're going to check, the bullet already checks for collision with enemies, so we don't need this code. But we should check collision with basically the player. I don't have a class for the player. I have to think about, am I going to create a class for the player or just an entity, give it some graphics, and have it move around and just have a global like player instance. You know what? I don't need to do any of this type checking. What I'm going to do is I'm going to see if E is game.player. So if we're colliding with the player, then we're going to stop our own callback. We're going to remove ourselves from the canvas, and we will stop the callback of the player. No. We will remove the player. No. We will just decrease score by 10. There's something I forgot here. So when we do here, there's a collision here. So let's create an explosion for a second when we collide. How do we want to create the explosion? I guess we'll just create an explosion object that takes care of all of that and just deletes itself after a while. Yeah, why not? So we will do, we'll just create an explosion object, and the place that will, and yeah, I'm just defining, I mean, I'm using this explosion object as if I've already created it, but I haven't. I'm just pretending I've created it, and then I'll create it later. So I'm creating my explosion, my fake explosion object. And let's see, that will take a position. So we're going to create the explosion object at, where should we create the explosion object at? At the current location. Let's do that first. We'll create the explosion object at self.position. Why not? Wherever we're at right now. And that's it. I think the explosion should take care of everything else. So, all right. So we got to create an explosion let me write these little things down. So we need to create an explosion. And I believe there was one other thing, player. We need to take care of the player as well. So I gotta write that down too. Okay. All right. We also need to create an explosion for when the bullet collides with an enemy. Okay, nice. That all looks good. Okay, let's go ahead and find the explosion, I guess, now, since we're defining so many things. So the explosion will be an entity. Yeah, why not? We'll make it an entity. And let's see. Self, it takes a position. Okay, and what will the explosion do is it will basically add its art, I guess. So let's see, self dot. It has a source. We're gonna set the source to asset/explosion .png, which I have downloaded, well, which I created myself. You'll see my beautiful art soon. Okay, so we set that, and then when this class is created, we have to make sure that it adds itself to the actual game. Actually, we can't just construct the explosion like this. We'll do something like game.addEntity explosion, and then the explosion after some time will remove itself. Yeah, I like that idea. So all right. So yeah. So that explosion will, when it's constructed, it will set its graphics, and then it'll get added to the game. And let's say it will also sound loader. It will use sound loader to load the explosion.wave file, and it will play it. Okay, so that looks good. So it will play it, and then after a while, it will remove itself. So we will do clock.schedule once. What do we want to schedule? Self.remove me. And we want to remove ourselves after 1 second. Let's put an underscore here. Remove me will take a delta time. We don't care about it. Ooh, okay. Remove me will basically. Oh man, I'm getting tired. I got this stand-up desk. It's making me tired standing. Okay, but I gotta get used to it, I guess. So the remove me will remove this entity from the game. Game.remove entity self, and it's not bound to anything. Okay, that's it. Nice, explosion has been defined. So we did the explosion. Now player we gotta take care of. All right. Okay, so let's go back to the widget class. Let's see how big this file has gotten. Wow, not too big for like an almost complete game. It's not too big at all. I guess we do need to define a player class because the player will have to, first of all, respond to the keyboard. Yeah, you know what? We're going to have to create a player class as well. Why not? So player, it is an entity as well, and okay, so it doesn't take anything. The source. Let me check the entity, make sure it's correct. Property for the source. Yeah, okay. Go back, and it's gonna set the source to player asset slash player.png, and here I don't want to use that one, I want to use this one. Okay, so player sets the source to player.png, and it also listens for keyboard, I guess, or for frame events, and then it moves. So we will, first of all, we're gonna game.bind to the onFrame. I guess we'll do our frame step. Why not? We'll call it, we'll just call it onFrame. Self onFrame. All right. And let's define our stop callbacks. Okay, we'll unbind this. Okay, so our init, we bind to the onFrame. What do we do? onFrame. Okay, so we're gonna move and we're gonna shoot here. So for move, and I forgot one more thing for the bullet. Let's go back to the bullet class, and when it's created for the bullet, we need to source, it will be asset slash bullet.png, and also it has to play a sound. So we will do that, I guess, here. We'll do sound is equal to sound loader load assets slash bullet.wave, I think, sound.play. Alrighty. And so the bullet creates a sound. Now we will go back inside. What was it that we were trying to modify? The player, yeah. So the player's onFrame move. So if game.keys pressed, so let's say if A is being pressed, then we want to move a little bit to the right. So first of all, let's define the step size. Step size will be, I guess, 200 times delta time, and so 200 per second, sure. And if A is it, you want to do self dot, let's do, so new x self dot position the 0th element, new y self dot position the 1th element. If A is pressed, we want to basically subtract from the x direction. If D, game.keys pressed, if D is pressed, we want to add in the x direction, and we don't care about anything else. And so what we're going to do is self.position equals new x, new y. We're going to update the position. Shoot. So if space, I believe it's called space, and I have to double check that later. So if space in if space is in game keys pressed, so if space is being pressed, Then we want to create a bullet. So game.add entity bullet, and for the position and speed. So for the position, we're just going to create a bullet at the same position that I guess the same position that the player is at. Yes. Maybe a little bit higher, but you know what? This won't look good because it's going to be created right where the player is. I should create it a little bit above the player. That's really what I should be doing. So yeah, that's what I should be doing, a little bit above. So let's see, X and Y. So for the X position and the Y position. So for the X, we will make it the player's position X. For the Y, we will make it the player's Y plus about 50 pixels, I guess, above it. And instead of creating it the player's position, we will create it at that X and Y. All right, that's it. Good. So we shoot, when we create the bullet, it's gonna make the bullet noise, it has the bullet graphics, everything. The player has the player graphics. Okay, one frame. We're gonna do that, stop callbacks, that's it. So let's think, the player, all right, when it's constructed, it sets its source properly, which will set its instruction properly. Okay, good. Then it listens to the frame event of the game, and it moves left and right, and it shoots. It spawns a bullet. When a bullet is spawned, let's go inside here. I guess let's go to a bullet. When a bullet is spawned, it sets its position, it saves speed, it sets its source, it plays a sound, it listens to the on frame. Everything seems to be connected well here. I'm sure I've made a mistake somewhere. But now it's time to go look at the main game widget, and let's make sure the setup is correctly. So we listen to the keyboard, we create a score, we have an on-frame event, this self.player thing. No, that no longer applies. Yeah, that no longer applies. Keys pressed, entities, schedule interval, sound, we want to play the music. Okay, good. Now, where do we actually create the player object? Because there is somewhere where we reference the player. I believe it was the enemy. Yeah, the enemy references the player. Yeah, game.player. So let's make sure we create that. So self.player equals, all right. We're gonna create a player. Let's see, where should the default position of the player be? It should be, the position will be along the x-axis. We will do 400, and on the y, 0. Why not? That's it. Man, I'm probably gonna get so many errors. That was a decent amount of code to write without running anything. Let's run it. Of course. All right, so let's see what the problem is. Most recent call last. So player object has no attribute instruction. How is that so? Yes, it does. It inherits from entity, and oh, my init always has to do super.init. I forgot. Super dot initialize the super class. Passing in nothing. We shouldn't get that anymore, but we should get another error probably. Yeah, game is not defined. So I know I have that error elsewhere. Let's go ahead and look at our entity class. Yeah, our entity defines a position, size, source. It creates properties for them that updates the instruction. Position, size. Oh, I found another bug here. Source. I guess, yeah, it's not really a bug. Yeah, but why not? Okay, so yeah, it puts a position, size, source, and it listens to it properly. So the bullet, anything that inherits from the entity, I need to make sure I call the super init. Bullet inherits from the entity, enemy inherits from the entity. Explosion inherits from it. Ooh, what am I doing? Help me out, autocomplete. Alright, now let's run. Alright, so we have in our main here. So right here, and then self.player. Oh, I see, game is not defined. So looks like we got ourselves a little tussle here. Okay, so when we're trying to create the game widget, it tries to its constructor of the game widget. So back up. We're trying to create the game variable, which creates the game widget. The constructor of the game widget tries to create a player. And the constructor of the player, we got ourselves a little southern tussle. There's a circular thing going on here. So let's see. All right, how do we resolve this? Okay, easy solution. All I gotta do is not create, we're gonna go to the game widgets constructor. We're not gonna create the player right when it's constructed. We will create the player here. There you go. And that should take care of our circular southern tussle. And all right, we got another problem here. So on frame takes 2 positional arguments, but 3 were given. Okay, so first of all, we need to get rid of this move step. We don't need it. Let's clean up a little bit. That'll help us out. So let's see wherever the on frame is being used. It's being used a little bit over here. Move step, self delta time. I think it's sender as well. Let's run it. Yeah, I believe the dispatching will tell you the sender and then delta time. So yeah, that is correct. I just need to change it in a few other places. So on frame, more down here, move step, sender, delta time, and on frame, change it right here. Now let's run it. Okay, starting application loop. All right, so we got this up and running, but there's nothing there. Nothing has been added. Let's see why not. Well, first of all, let's see if we get any weird errors spitting out to our log. Let's clear, and let's kill the terminal, and let's run. Now let's look at our log. So everything looks good. Okay. Unable to load music.wave. Alright, but that's not really a problem. music.wave. Let's see where music.wave is. Yeah, that's no longer the case. It should be assets/music.wave. Let's get rid of this and let's run it. Music works now, but still nothing is being created. Alrighty. Wait, does it ever get added? No. Aha, that was the problem. Space. We're gonna go inside the player here and we're gonna print the, let's just print the value of game.keys pressed. See all the keys that are being pressed. Space, okay. So alrighty, run it. Ooh, yeah. Okay, no problem. We're no longer gonna print, so we can see what's going on here. We're gonna get rid of this debug panel, so we got more room. Okay. So as soon as we create the bullet, we got a problem. For E in game.colliding entities, type error none. For E in game.colliding entities, so game.colliding entities returns nothing. How is that so? Yeah, so the way that we're adding and removing keys is not the same. I made a mistake. The text and the second element of the key code are not the same. So we're gonna go by the key code actually. So here we're not gonna add the text, we're gonna do key code, the second element, I believe. Alright, so key code, the second element, that's what we're gonna go by here. And our moving should still work. Good. And now let's AD, but if I run the file, let's see what is printed. Okay, and now we're gonna scroll down. Here we're only gonna shoot if space bar is pressed. Let's move it up here. And we still get that none type. Oh my gosh, it never returns anything. Wow, that was a silly bug. You guys probably saw this, but unfortunately you can't tell me anything. Alright. That was it. You like that bullet sound? That little whoosh. Let me make sure that you guys can hear that. It's not my sound. I just wanted it. Alright. Okay, so that's figured out. Let's go ahead and get rid of this test. And let's make sure that we do create a bullet when we press space. So let's see. let's get the freaking let's get the enemies to spawn from the top down. All right. So let's see. How should we do that? Over here, I guess we'll do it, or maybe in the constructor. Why not in the constructor? We'll do it in the constructor. But in the constructor of the game widget, the player does not exist yet, and I believe the entities depend on, or I believe the enemies depend on the player. Yeah, game.player, they depend on game.player, which is a none type. It does not exist yet. All right, so here, okay. So what we will do right over here is we're gonna create a function that will periodically spawn these I guess these things. But first of all, let's go ahead. Why don't we just do it in the initialization of the game? So what we will do here is clock.schedule interval, and we will do spawn enemies function. We will have it spawn, I don't know, I guess every 3 seconds. Every 2 seconds, since we got that crazy gun right now. Every 2 seconds, we will do that. Okay, so we will define this function now. And what we're gonna do is random x. So we're gonna pick a random x. We need the random module. So import random.randint. All right. So we're gonna get a random from 0 to the window.width. So the width of the window. So some random x along the top of the window. For the y, we will make it be window.height. So at the top of the window, that's where we're gonna spawn an enemy. So we're gonna create an enemy. So let's see, self.add entity, an enemy, and the position is random x and that y position. Speed 100. Why not? We can randomize speed too. Let's say random speed, random.randint. It'll be random between 100 to 500, I guess. And why not? We'll pass that into the enemy. So we'll do random speed. Uh-oh. I'm typing. All right. Okay, spawn enemies. This might fail, but if it does, it's okay. Print whatever's being pressed, man. Let's look at all of our print statements. I'll key up print text. Get rid of that, and let's make sure we're no longer doing that. Okay, excellent. Now we want, the problem is we have scheduled that function and nothing is happening. So let's see, why not? Every 2 seconds we want to call this random x, y, add entity, enemy. Why is this not happening? Is this function even being executed? Okay, so add, we know add works, Let's go inside the enemy and make sure everything here works. Position is set properly. Oh, we are never setting a source. So self.source equals asset/enemy enemy.png. And also, what else do? We bind on the on frame of the game, and we move. We should be moving a little bit down, so minus step size. That's why we didn't see anything. Let's go ahead and run. Whoa! Oh man! So some of them are moving way too fast. Let's go back inside our game widget and change from 100 to 300 should be enough, because our speed is only 300, boys, so we can't go too fast. Alright, so what else was I going to do? Let's, let me make sure that the speed is good. So we will go in the bullet, and okay, if is instance enemy. So it must be our collision that is actually not working. Okay. So let's see if our collides works first of all. So we will also, let's see, we'll create another player. So can we create two players? I want us to make sure. Yeah, why not, I guess. So we'll do player 2 equal new player. Player 2 dot position. We will put him a little bit more to the left, I guess. Why not 0, 0? Okay. Let's see if game.add entity player 2. Let's see if now that will work. I didn't even put that for that. Damn. Okay, nice. So we got two players, but that wasn't even my point. I'm trying to see if they're going to collide. So let's put the other player at the same exact place, and then we're going to see if game.collides. Oh my god. So we're going to see if game.player and player 2 are colliding. This better be true. True, that is working. And if we do move player 2 dot position to 0, 0, then better print false. Good. So we know that's working. Now what about the colliding? So we're going to print the length of game.colliding entities with game.player. And right now, I guess since the other one is at 0, 0, it should be nothing. Okay, that's weird that something is colliding. Okay. But what is colliding? Let's go see here. If oh, and it does not. First of all, that's false. Okay. So 0. There we go. Oh man, I kind of like this double thing. All right. You know what? Thug life. We will put this one at like, let's see, we will do window on the X. We will do window width divided by 3, so 1/3. And the other one, okay, so we'll put 0 on the Y again, and we'll do window.width divided by 3, but we will do window.width minus. So from the right, this one is from the left. Now let's see, how does it look? Wow, nice. First of all, this comes. Why is it a nice background spawn rate a little bit? Okay, so the explosions appear. There's a couple problems. The explosions appear at the wrong place. The spawn rate of the spawn rate of the enemies is weird. So let's go change both of those. So the spawn rate, first of all, we'll go to our spawn enemies, and we will create a couple of them. Why not? So we will put a for I in range, and why not we do I don't know, 5 of them? Sure. So 5 times we will spawn. Let's run and check this out. Now let's go fix the problem of the explosion. So in the bullet, when it has collided with stuff, okay, so when it collides with an enemy, it will add an explosion, and then it will stop its own callback, removes itself, and remove the enemy. So it adds an explosion. Now the explosion constructor just takes a position, create a sound, and it will play the sound. And it will, oh, it never sets its position. So self.position equals position. And let's see if this works. They disappeared a little too late. 1 second is too much. We will do 0.1 1/10 of a second. They will stay for 1/10 of a second. So one more thing that I want to do, I actually don't like, I don't like the fact that I can spawn a crazy amount of freaking bullets, man. So for the shoot, I'm gonna have a little like, maybe I'll have another function that as long as the space bar is down, it will shoot. Yeah, that's what I'll do. So for the player, we will have this on frame. We will go ahead and rename that to, I guess, move step. And we will also bind another, and we'll call this shoot step. And all right, so for the shoot step, actually shoot step, we don't want it to be on the game. We want to do our own thing. So we'll do clock.schedule interval and shoot step. We want to schedule that every 0.5 seconds. So we want to shoot every 0.5 seconds. And we're going to save that shoot event as shoot event. So then we can cancel it. I think it's cancel. All right, so shoot step, what we're gonna do is, so every half a second, then we're gonna check if the space bar is down and shoot. All right, let's run it and make sure we can't. Missing one required position argument, delta time, shoot step. Shoot underscore step is missing. Oh, yeah, this is not a dispatch. There we go. Run and should work. Include my background because I have a pretty nice background. So we're gonna go in here and we're gonna put my background. So we're gonna add a rectangle. Source is gonna be asset/background.png. The position is gonna be 0, 0. And the size, I believe it will be determined from the picture. Oh, tiny. So let's make it the same as the window A. Right, so for the size, window.width, window.height, and run it. Hoo-wee! Wow. Not bad. This framework is pretty nice. Okay. Make sure that our score shows up. So let's put the score after. Format our document here for us. Okay, nice. And let's make sure the score shows up. Okay, so now we got to make sure our score actually gets incremented and decremented. So we're going to go into the bullet. And when it collides, when the bullet collides with these things, we're gonna actually set our score. So game.score plus equals 1. Let's make sure that the game widget's score property, the setter, will actually update the instruction. Let's see. If the score does not get updated. Okay, so the score setter, let's see if it gets executed. The score setter never gets executed. Oh, I didn't have a debugger attached. No wonder. What a fool I am. that one thing. Score label.refresh. And then I'm confident that was it. We will run and not debug. Oh man, I lose 10 points every time one of them goes below that game. Yeah, that's a little too hard. Let's go to the enemy and make sure we lose less points when they go down. Minus 10. Oh wait. No, just minus 1. Minus 1 is all we need. Let me Google how to do that really quick. So yeah, I guess we'll put it here. So Kivy drop text on canvas. There's a guy I found that has done that. And font underscore size. Self.color. Okay. Anyways, font underscore size, we will make it 20. So font underscore size. We'll go to the game widgets, label, make it a little bigger. Yay, there it is. I'm trying to check my time. Alright, so that's it. Exit that so I can talk for a little bit. Okay. I'm sorry about the phone. I'm a little bit tired, so I don't really even feel like putting it on vibrate. But anyways, overall, I think that the Kivy framework is pretty nice for game development because it gives you that nice canvas that you can draw anything on. It gives you the ability to play sound. And it gives you a pretty good way to like schedule things. Like whether you want to do something every couple of seconds or whether you want to do it one time a couple of seconds in the future, or if you want to do something every frame. And that's really, really important. The event handling and like the scheduling facilities are going to help you with games quite a bit. So that's it for this tutorial. I hope that you guys enjoyed this tutorial. I really, really enjoyed making this. And if you did enjoy it, go ahead and check out some of my other tutorials. I have a lot of tutorials on game development in general using various frameworks. And I also have some like math and a few physics tutorials if you're into that as well. So if you like this tutorial, check out one of my other ones. Or alternatively, if you really like this and you want to see more Kivy tutorials, just go ahead and leave a comment. And if enough people want to see more, I will delve more into Kivy and create further tutorials on it, whether I'm just using it as a GUI framework or if I'm using it to create games. That's up to you guys. Just let me know what you want in the comments and I'll think about that. Let's see. So yeah, I do recommend this framework for basic game development. It was pretty fun. And then if you ever want to add GUI to your game, like it's an entire fully fledged, like nice, complete GUI framework. So I definitely recommend it for this. I also wanted to mention that you should definitely check the description of this and all my videos because I always upload my code and I give you guys a link to the code. So this is no exception. I will be uploading all of this code on a GitHub repo, and then I will send a link to you guys. As always, thank you so much for watching, and I hope to see you in another one of my tutorials. Bye-bye.